everybody, this is my first video that I'm making for Math OED2 2.3. This is solving systems of linear equations using elimination, or as you can see, the textbook refers to it as addition. The truth is that you can use either addition or subtraction. I think because of the level of course this is, they discourage you from subtracting to equations simply because it's easy to make sign errors. So they force the issue of adding and not subtracting to the extent that they don't even call it elimination anymore, which is what you're really doing. You're eliminating one of the variables and then solving for the other one. That's really what's happening, okay? So let's get started. So I always like to write out some steps, okay? So for this problem, the first thing we need to do is we need to obtain two terms, okay, that have the same variable. So either both x's or both y's. I guess I should write that containing the same variable, okay, with the same coefficient, right? That's the number next to the variable, but opposite signs. Okay, that is our goal. Now, since this is my first video, I picked an example where that was already done for us. So you can see here that our y has a coefficient of -4 in the first equation, and it has in it a coefficient of +4 in the second equation. So I'm going to show you down here exactly precisely what will happen if I simply add these two equations together. Okay, so let me use a different color here. All right. So I'm literally adding these equations. So I have 3x plus 5x, that gives me 8x. I have a -4y and a +4y, and hey, gee golly, look at that. They go away. They cancel each other out. So that's why you want the same number and opposite signs, because, right, opposite signs, same number, that means they go away, right? -4, +4, cancel out. -2, +2. Doesn't matter what it is as long as they're the same number, opposite signs. All right, I think I beat that horse to death. Then we have 8 minus 24. That gives us -16. And then, right, our goal was, again, to eliminate a variable. We eliminated y, right? 0y is nothing. It's just 0. So then we have successfully, I hope, successfully solved for x, okay? The annoying thing you might think about the systems of equations, right, is that we're not just solving for one variable. As you can see in the equations, we have two variables. So you might say that we're only halfway done. So you can pick either equation at this point. It doesn't really matter. So I'll pick 3x minus 4y equals 8. Okay, and I will, just like we did with the substitution problems, I will use my substitution property of equality, and wherever I see the x, instead of writing x, I will write -2. Okay, so 3 times -2, just kidding, it's -6. -6 minus 4y equals 8. Okay, I'm going to move us over here. -6 minus 4y is 8. Plus 6 plus 6. Of -4y equals 14. I'm going to divide both sides by -4. Okay, and we get y is equal to -3.5. Okay, so our final answer here is that x is equal to negative 2 and y is equal to negative 3.5. Okay, you can just write the x and the y part, or you can write it as I did as an ordered pair. But this is the first part of your answer. This is the second part of your answer. I kind of stopped writing out the steps. So let's go back and fill those in. So we obtained the two terms. They contain the same variable with the same coefficient but opposite signs. Okay. We added them together to eliminate one variable, right? And we solved for one variable, and then I'm kind of out of room here, but then we use substitution to solve for the other variable. Okay, so if you are ever not confident or unsure of your answer, one thing that you can do is you can go to Desmos.com. Okay, and the beauty of Desmos, besides the fact that it's absolutely free, they really should pay me. I do so much advertising for them for free, is that unlike a calculator where you have to rewrite these in slope-intercept form, you can literally type both of these equations exactly as they are into Desmos and graph them, and then wherever those two lines meet would be your solution. So you can go online, graph those, look at the graph, and make sure that your point of intersection is at x equals negative 2, y equals negative 3.5. And if it is, then you know that you've done this problem correctly.